The air trembles above a torn Italian hillside. Dust drifts over cracked stone walls and olive trees burned black by artillery fire. It's early 1944, near the battered town of Anzio. American soldiers crouch behind sandbags, their helmets gleaming faintly under the overcast sky. In the distance, German mortars thump rhythmically, sending plumes of soil into the air. Then, a sound unlike anything the front has heard before. A high-pitched whine builds from the valley floor, not from aircraft, not from tanks, but from a convoy of small, open-topped vehicles. Jeeps, dozens of them. Each one stripped down and refitted with strange metal racks welded to the frame. Engines rev, sparks leap. Within seconds, trails of smoke burst from their mounts. Streaks of fire rip through the fog. The sky glows orange as dozens of rockets arc upward, screaming toward the German lines. The sound is both mechanical and primal, like thunder born from gasoline and steel. Across the valley, German observers freeze behind their binoculars. They whisper to one another, trying to make sense of what they're seeing. Light reconnaissance cars turned into mobile rocket batteries. To them, it defies logic. To the Americans below, it's just another field improvisation. The smoke thickens, the ground shudders. When the echoes fade, the hillside is quiet again, except for the low hum of Jeep engines idling, ready to move. In that moment, the symbol of American mobility becomes something entirely new, a weapon of invention. And behind this strange transformation lies a story that begins not on the battlefield, but in the factories, workshops, and restless minds of wartime America. In the late 1930s, the United States Army faced a problem of mobility. Europe was already aflame, and Germany's blitzkrieg had demonstrated the devastating effect of fast, mechanized forces. Tanks moved in synchronized waves, infantry followed in trucks, and the battlefields of Poland and France revealed that speed could decide the outcome before strategy even fully unfolded. The Americans, observing from across the Atlantic, understood that any future conflict would demand a vehicle that could traverse mud, sand, snow, and mountains with equal ease. A universal workhorse of the battlefield. The solution came in the form of the Jeep, a lightweight, four-wheel drive vehicle designed to carry troops, supplies, and weapons into places heavier trucks could not reach. Early prototypes emerged in 1940, the result of an urgent Army requirement for a general-purpose vehicle. Several manufacturers competed to meet the specifications, most notably Bantam, Willys Overland, and Ford. Each prototype was evaluated for speed, durability, and simplicity of repair. Army officers demanded a vehicle that could be maintained with minimal tools, repaired by soldiers in the field, and manufactured in large numbers without disrupting civilian automotive production. By 1941, the WW2 Jeep had reached a form close to what would become iconic. Its wheelbase was short, suspension high, and engine compact yet reliable. Soldiers quickly discovered that its strength lay not only in mechanical simplicity, but also in versatility. Flat plains, rocky hills, muddy riversides. The Jeep navigated them all. It could carry a small crew, light weapons, or supply crates, and its small profile made it less visible to enemy artillery. The American Army began deploying Jeeps in North Africa and the Pacific, testing their endurance against harsh terrain, sandstorms, and tropical rain. But the Jeep was more than a transport vehicle. Engineers and ordnance officers began to see its potential as a platform for innovation. During early operations, soldiers improvised mounts for machine guns and light mortars, realizing that the vehicle's light frame could support more than just passengers. Jeep crews would weld brackets, nail wooden supports, and strap rockets and bazookas to the hood and sides. Field manuals provided guidelines. But the real ingenuity came from those willing to experiment under the threat of combat. The need for mobile firepower became especially acute as American forces encountered well-entrenched German positions. Static artillery could destroy bunkers and fortified positions, but it lacked speed. Infantry carrying portable weapons faced exhaustion and exposure. The Army sought a solution that combined the firepower of artillery with the mobility of the Jeep. Conceptually, it was simple. Put rockets on wheels, drive within striking distance, fire, and retreat before the enemy could respond. Engineers in workshops across the United States began adapting existing technology. The 2.36-inch bazooka, already in use for anti-tank operations, was one candidate. The 4.5-inch rockets used in experimental heavy artillery provided a larger, more destructive option. Mechanics calculated recoil, weight distribution, and engine output. They conducted tests on abandoned airfields and in remote deserts. Each modification taught new lessons about stability, aiming, and the resilience of a vehicle under explosive stress. By the winter of 1942, prototype rocket jeeps were under evaluation. Soldiers trained in firing from the hood or rear racks, engineers studied the effect on steering and suspension, and ordnance officers drafted reports on operational feasibility. The experiments were not without risk. Rockets misfired, mounts broke, and engines overheated from sustained bursts. Yet, the combination of ingenuity, necessity, and the adaptability of the Jeep produced results that far exceeded expectations. Across the Atlantic, German engineers watched American vehicle production with mild curiosity. Reports from reconnaissance indicated that the United States was producing thousands of light vehicles at a pace and cost that Germany could not match. Yet, the idea of a Jeep carrying more than men and supplies, a vehicle that could fire rockets, would not reach their attention until the battlefield revealed it. American engineers understood a simple truth. Mobility multiplied by firepower could become a force multiplier far beyond conventional artillery. The foundation for what would astonish the German military was not laid in combat, but in workshops, drawing rooms, and test fields. It was born from a culture of improvisation, from a mindset that valued adaptability over rigidity and speed over tradition. The Jeep, initially conceived as a general-purpose vehicle, was about to become something else entirely. A rolling arsenal capable of bringing destruction from unexpected angles. Soldiers in North Africa and Italy began to notice the first prototypes in their convoys. Small brackets on the hood hinted at the innovations to come. Mechanics carried extra clamps and welding tools, ready to modify the vehicle according to the mission. Every movement of the Jeep, over hills, through rivers, across shattered villages, became a test of its potential as more than transport. It was in these moments, far from the front lines, that the idea of weaponized Jeeps matured. American ingenuity did not wait for bureaucracy or formal approval. It acted in real time, responding to immediate tactical needs. Field engineers welded, drilled, and tested, recording successes and failures. By 1943, the Army had documented multiple methods to attach rockets and light artillery to Jeeps, paving the way for deployment in the European theater. The transformation was incremental but deliberate. A vehicle designed for reconnaissance and supply was steadily becoming a mobile weapons platform. Soldiers grew accustomed to seeing Jeeps not merely as transport, but as a means to carry the fight directly to the enemy. These early experiments would soon shock German engineers, who, accustomed to rigid design and heavy artillery doctrine, could hardly imagine a small, wheeled vehicle unleashing concentrated rocket fire across a battlefield. The stage was set. Across fields scarred by shelling and villages reduced to rubble, American ingenuity was about to demonstrate a lesson that would reverberate through both armies. Even the humblest engine, when guided by necessity and skill, could become a weapon of significant force. By 1943, the American Army had fully embraced the concept of field improvisation. Engineers and ordnance officers recognized that conventional weapons could be adapted in unexpected ways, and the Jeep offered the perfect platform for experimentation. Unlike tanks or heavy artillery, it was small, fast, and nimble, capable of reaching positions that larger units could not. It was this combination of mobility and adaptability that inspired the idea of mounting rockets directly onto a vehicle designed to traverse any terrain. The first practical experiments drew on existing technology. The 2.36-inch bazooka, though initially intended for anti-tank operations, demonstrated that a portable rocket could be fired accurately from a lightweight frame. Meanwhile, heavier 4.5-inch rockets, adapted from experimental artillery units, offered a longer range and greater destructive potential. Mechanics and engineers had to calculate the effect of recoil on the Jeep's chassis, the strain on suspension and steering, and the placement of rockets to prevent accidental ignition. Test fields became laboratories where trial and error determined success. In remote deserts and abandoned airstrips, soldiers watched as prototypes fired rockets in rapid succession. Each launch produced a cloud of smoke, a crackling roar, and a test of the vehicle's durability. Engines overheated, tires shredded under stress, mounts failed. Yet each failure provided critical information. Soldiers learned the precise angle for maximum range, the correct placement of stabilizing brackets, and how to distribute weight so that the Jeep could fire without flipping or losing control. These experiments were often improvised. A steel rack welded overnight, a firing trigger cobbled together from spare levers, a seatbelt securing a rocket to prevent rolling. The culture of improvisation was reinforced by necessity. In the mountainous regions of Italy, infantry units needed firepower that could climb hills and navigate narrow roads where tanks could not follow. The rocket Jeep allowed commanders to concentrate fire on German fortifications with a speed and flexibility impossible for conventional artillery. Field manuals began to incorporate these lessons. But many modifications were still done at the discretion of individual units. The ingenuity of soldiers in combat zones often outpaced official doctrine. American ingenuity did not exist in isolation. The United States observed Soviet and German practices, adapting ideas to their own logistical and tactical needs. The Soviet Katyusha rocket launcher had demonstrated the psychological effect of mobile, concentrated rocket fire. German Nebelwerfer units had shown how a few well-placed rockets could disrupt infantry formations and defensive positions. American engineers asked a simple question: if heavy rocket artillery worked, why not scale it down to a vehicle as versatile as the Jeep? The answer lay in combining mobility with surprise. A light vehicle that could appear where least expected, deliver concentrated fire, and disappear before enemy retaliation. Within Army workshops, the process moved quickly. Engineers designed mounting systems that could hold multiple rockets, yet fold or retract to maintain the Jeep's maneuverability. Firing mechanisms were adapted from bazooka triggers, allowing a single soldier to launch rockets from the driver's seat. Brackets and steel frames were reinforced, tested, and retested. Logistics officers calculated ammunition loads, ensuring that each vehicle could sustain repeated bursts without overloading the chassis. By 1943, dozens of experimental units were ready for combat trials. Field trials revealed both the potential and limitations of the design. Rockets were accurate at short ranges, but became unpredictable at longer distances. Recoil occasionally rocked the vehicle, throwing off aim. Engines struggled when firing multiple salvos in succession. Yet, even with these imperfections, the impact was undeniable. Small units equipped with rocket jeeps could strike quickly, sowing confusion among German forces and supporting infantry assaults in ways conventional weapons could not. Commanders began to recognize the strategic advantage of using mobility and firepower together. Reports from early operations in Italy emphasized the psychological effect on German soldiers. Encounters with rocket-firing jeeps left enemy troops stunned. German observers noted how light, seemingly harmless vehicles unleashed volleys of rockets and disappeared into cover, leaving devastation in their wake. Intelligence officers recorded sketches and accounts attempting to understand the mechanics. But the innovation lay not in sophistication, but in the clever use of what was already available. Simple engines, welded racks, and carefully aimed rockets had created a battlefield game-changer. This period also highlighted the collaborative nature of American wartime innovation. Frontline soldiers, mechanics, and engineers worked together to refine the vehicles. Every mission provided feedback. Which angles produced the best range, how to prevent premature ignition, how to reinforce the frame for repeated use. These lessons were incorporated into subsequent models. What began as an improvised field solution was evolving into a standardized approach, combining ingenuity, practicality, and tactical necessity. By late 1943, the concept had matured enough for official deployment. Rocket-equipped jeeps were assigned to specialized units, tasked with rapid assault and support. They operated alongside infantry and armored divisions, their mobility allowing them to bypass obstacles and strike where traditional artillery could not. The effectiveness of these units would soon be revealed on a larger scale, and the German military, accustomed to precision and heavy engineering, would be forced to confront a weapon born not from doctrine, but from ingenuity and necessity. The stage was now fully set for the American Jeep to become more than a vehicle. It was a mobile platform, a surprise artillery unit, and a symbol of how practical engineering could transform the battlefield. The lessons learned in workshops, deserts, and test fields were about to be applied under fire, and the results would leave an indelible mark on both sides of the conflict. In the midst of battle, the human element often determined the success of innovation. For the soldiers operating the rocket-equipped jeeps, every mission was a test of skill, courage, and improvisation. Mechanics who had welded brackets in quiet workshops now found themselves firing live rockets under enemy fire. Each operator needed to understand the limitations of the vehicle, the weight distribution of the mounts, and the precise timing of ignition. Mistakes were unforgiving. A misaligned rocket could damage the Jeep, injure the crew, or waste precious ammunition. Yet, amid this danger, a sense of pride and ingenuity thrived. Soldiers referred to their vehicles not just as transport, but as extensions of their own resourcefulness, embodying the adaptability that defined American troops in theaters from Italy to Normandy. Tactically, the rocket jeep introduced a new dimension to mobile warfare. Infantry units could call on these vehicles to deliver concentrated rocket fire in areas inaccessible to conventional artillery. Narrow mountain passes, destroyed bridges, and congested villages no longer limited the American advance. The ability to fire and relocate in seconds allowed commanders to strike German positions with unexpected precision, creating openings for infantry to advance. In battles like Monte Cassino and Anzio, these vehicles provided suppressive fire that was both mobile and unpredictable, forcing German forces to constantly adjust defensive positions often under the threat of being outflanked. Technologically, the innovation was deceptively simple. Existing rocket designs, such as the 2.36-inch bazooka and the larger 4.5-inch artillery rockets, were adapted to the Jeep's frame. Engineers had to calculate every variable: the recoil generated by multiple launches, the stress on suspension and steering, and the placement of rockets to avoid damage to the engine. Launch racks were welded with reinforced steel, sometimes folding down to allow the Jeep to traverse obstacles. Triggers were modified so that a single operator could launch multiple rockets in quick succession. Despite their apparent simplicity, these modifications represented a sophisticated understanding of both mechanics and battlefield requirements. The psychological effect on enemy troops was profound. German soldiers, trained to fear tanks, artillery, and aerial bombardment, often found themselves facing an unexpected and bewildering weapon. Reports describe light vehicles appearing from ravines or behind walls, firing rockets with little warning, then disappearing before counterfire could be organized. The unpredictability created fear and confusion, disproportionately amplifying the effectiveness of relatively small numbers of rocket jeeps. Soldiers began to nickname the vehicles miniature artillery or the devil's cars, reflecting the combination of awe and frustration they inspired. Meanwhile, the German military observed with a mix of disbelief and professional curiosity. Intelligence reports detailed the use of light vehicles as rocket platforms, noting the audacity of converting an engine designed for transportation into a weapon capable of altering the dynamics of battle. Engineers in Germany were trained to value precision, heavy armor, and well-established artillery doctrines. The improvised American approach challenged these assumptions, demonstrating that ingenuity, speed, and adaptability could compensate for the lack of mass or armor. This divergence in engineering philosophy highlighted a broader contrast between the two militaries. German doctrine emphasized calculated efficiency, while American doctrine allowed space for improvisation in response to immediate tactical needs. On the logistical side, challenges were constant. Rockets were bulky and prone to misfires. Ammunition had to be carefully stored and loaded to avoid accidents. Jeep frames, while versatile, were not designed to handle repeated rocket launches. Crews learned through trial and error which configurations maintained balance and which caused the vehicle to swerve dangerously. Supply chains adapted, ensuring that specialized units received both vehicles and sufficient rockets to sustain operations. Every deployment became a study in risk management, balancing firepower with mobility and crew safety. The integration of the rocket jeep into combat units also demonstrated the importance of teamwork. Infantry, engineers, and drivers coordinated their actions with precision. Forward observers would identify targets, drivers positioned vehicles within effective range, and operators launched rockets in rapid sequence. This synergy amplified the effectiveness of each launch, turning small teams into formidable tactical units. It was not the firepower alone, but the coordination, adaptability, and human skill that allowed the rocket jeeps to achieve results beyond what their mechanical design might suggest. By the end of 1943, these angles, human ingenuity, tactical mobility, technological adaptation, psychological impact, and logistical coordination had combined to create a weapon that was as innovative as it was effective. Each rocket fired from a Jeep represented more than mechanical function. It was a testament to the capacity of soldiers to adapt, improvise, and overcome limitations imposed by both terrain and conventional doctrine. The battlefield was no longer just a contest of numbers or armor, but of creativity and execution. As American units prepared to deploy these vehicles in larger numbers, the German military's astonishment would grow. Reports circulated in officer meetings and engineering briefings. What appeared to be a simple transport vehicle had become an unpredictable, highly mobile weapon system. It challenged existing tactical assumptions and forced a reconsideration of battlefield strategy. For the first time, both sides recognized that innovation did not always emerge from heavy machinery or formalized research. Sometimes, it emerged from the marriage of necessity, imagination, and the humble engine of a Jeep. The next section will expand on additional perspectives, including the German reaction, logistical considerations, and the long-term legacy of this innovation, showing how these small vehicles reshaped both immediate tactics and post-war military thought. From the German perspective, the rocket Jeep was both a curiosity and a source of concern. Reports filtered back from the front lines describing small, agile vehicles delivering sudden volleys of rockets and disappearing before counterfire could respond. Engineers and officers attempted to analyze these vehicles through sketches and battlefield accounts, trying to determine whether they represented a new form of artillery or simply field improvisation. To them, the notion that a light transport vehicle could carry concentrated firepower was almost inconceivable. German military culture emphasized heavy, precise engineering and layered defenses. The idea that soldiers could create a viable weapon system from existing civilian platforms seemed reckless, and yet the results were undeniable. The logistical angle of the rocket Jeep revealed another layer of ingenuity. Rockets were heavy, delicate, and prone to misfires. Ammunition had to be loaded carefully, secured during travel, and stored in quantities sufficient to sustain rapid attacks. The vehicles themselves, while agile, had limits. Repeated launches could destabilize the frame, damage suspension components, and overheat engines. Crews learned to balance the number of rockets carried against the vehicle's mobility. Field engineers developed solutions: reinforced frames, angled racks, and reinforced tires. Supply officers devised new loading protocols and pre-positioned munitions to keep rocket teams effective during extended operations. Each adjustment reflected a practical understanding of the interplay between mobility, firepower, and sustainability. German observers were particularly fascinated by the speed with which American forces adapted to tactical challenges. In the mountains of Italy, for example, German defensive lines often assumed security behind rugged terrain. Rocket Jeeps moved swiftly over hills, across ravines, and along narrow roads, bringing firepower where it had been considered impossible. German intelligence noted that even when facing superior numbers or heavier weapons, American units used these vehicles to exploit gaps, disorient defenders, and create openings for infantry. The shock of unpredictability, combined with concentrated firepower, forced German commanders to reconsider conventional defensive strategies. The legacy of the rocket Jeep extended far beyond immediate combat effects. Post-war evaluations by both American and German engineers recognized its influence on the evolution of mobile weapon platforms. The combination of speed, adaptability, and light firepower became a template for Cold War vehicles, influencing designs from the M38 Jeep to armored reconnaissance vehicles equipped with missiles. Engineers studying the phenomenon noted that the innovation was not rooted in expensive or complex technology, but in understanding how to integrate existing tools into a cohesive, functional system under the pressures of combat. This principle, making the most of what is available and adapting it to new challenges, became a core lesson in modern mechanized warfare. The German reaction also underscored the cultural differences between the two militaries. German engineering emphasized meticulous planning, standardized equipment, and predictability. The Americans, by contrast, often allowed room for improvisation, granting soldiers and engineers the freedom to test ideas in real time. Rocket Jeeps exemplified this approach. A field modification, born out of necessity, could become a tactical asset almost overnight. This contrast highlighted a broader philosophical divergence in how each nation approached problem-solving in war, with innovation sometimes emerging more effectively from practical necessity than formal design processes. On the battlefield, the effectiveness of rocket jeeps relied heavily on coordination. Forward observers identified targets, drivers positioned vehicles for optimal firing angles, and operators launched rockets in rapid succession. Small units became self-contained strike teams, capable of delivering artillery-level firepower while remaining mobile and difficult to target. Infantry units quickly learned to call on rocket jeeps for support, integrating them into larger assaults and using them to suppress fortified positions or disrupt enemy movements. The combination of mobility and firepower forced German units to adapt quickly, often reacting to threats rather than initiating them. The long-term impact on military doctrine was significant. Lessons learned from rocket jeep operations informed post-war planning for mobile artillery and reconnaissance vehicles. Vehicles designed for transport could be adapted to carry missiles or rockets, creating flexible units capable of rapid strikes. Engineers studying these innovations emphasized the importance of modularity, adaptability, and the capacity for field modification. The idea that a single vehicle could serve multiple roles, reconnaissance, transport, and fire support, became central to modern military thinking, illustrating how a small innovation in one theater could ripple across decades of military design. Even within American ranks, the success of rocket jeeps reinforced the value of practical ingenuity. Soldiers who had improvised mounts, tested firing angles, and coordinated with infantry learned that the battlefield rewarded initiative and experimentation. Reports circulated praising inventive teams and highlighting field modifications that outperformed official specifications. This ethos, the freedom to adapt, test, and innovate, it became part of the American approach to warfare, emphasizing flexibility over rigidity, creativity over bureaucracy, and action over hesitation. Ultimately, the angles of human skill, tactical mobility, technological adaptation, enemy reaction, logistical innovation, and strategic legacy all converged to make the rocket jeep more than a simple modification. It was a symbol of ingenuity under pressure, a tactical surprise weapon, and a catalyst for evolving military thought. Soldiers, engineers, and commanders all contributed to an innovation that challenged assumptions, reshaped battlefield dynamics, and left a lasting mark on the way armies approached mobile firepower. The lessons from these angles foreshadowed the moment when improvisation met reality on the battlefield, the point at which jeep-mounted rockets would decisively alter engagements, forcing German troops to confront a weapon that combined speed, surprise, and destructive capability. This convergence of preparation, ingenuity, and tactical application led directly to the turning points that defined rocket jeep operations in Italy and Normandy. The winter of 1943 brought bitter cold to the Italian front. Snow dusted the jagged peaks surrounding Monte Cassino, and the ruins of villages bore silent witness to months of relentless artillery. German defenses were fortified, entrenched, and seemingly impenetrable. American and Allied commanders sought ways to break through, methods that relied not just on brute force, but on ingenuity. Among the solutions emerging from workshops and test fields, the rocket jeep was ready for its first major trials. Units equipped with these vehicles moved cautiously along narrow roads and forested ridges. The jeeps, stripped of unnecessary weight and reinforced with welded racks, carried an array of rockets, some small, some large, all designed to devastate enemy positions with concentrated, mobile firepower. Forward observers scouted the German lines, identifying machine gun nests, fortified bunkers, and artillery positions. Once in position, the jeeps would advance, engines whining, smoke trailing, and unleash a sudden coordinated volley of rockets. The impact was immediate. Bunkers crumbled, defensive positions were disrupted, and the element of surprise created openings for infantry assaults that would have been impossible with conventional artillery. At Anzio, the rocket jeeps proved their mobility and tactical utility. Narrow streets and uneven terrain restricted tank movement, but the light vehicles darted from alley to alley, firing salvo after salvo before retreating to cover. German soldiers, trained to expect tanks and conventional artillery, struggled to respond. Reports from German intelligence described small, inexplicable vehicles appearing at multiple points simultaneously, firing rockets and vanishing. Morale among the defenders began to waver. The unpredictability of these attacks forced commanders to disperse forces, weakening the cohesion of defensive lines. The first recorded combat success of a rocket jeep unit came during a coordinated assault on a hill overlooking a vital road junction. A small team of 3 jeeps positioned themselves on concealed ridges. The engines hummed softly as soldiers checked angles and ammunition. On command, rockets fired in rapid succession, streaking across the valley and detonating among German emplacements. Machine gun nests were silenced, artillery pieces disabled, and infantry positions thrown into disarray. The effect was disproportionate to the number of vehicles involved. A handful of rocket jeeps accomplished what would have required a battery of field artillery. The integration of rocket jeeps into larger operations highlighted their strategic value. During combined assaults, these vehicles provided suppression fire, forced enemy units to relocate, and created temporary windows for infantry and armored advances. Coordination with tanks and mortars amplified the effect, turning each strike into a multi-layered assault. Soldiers reported a mix of awe and relief. A small, open-topped jeep could deliver destruction in seconds, enabling advances that would otherwise have stalled under entrenched German fire. Field engineers continued to refine the design even as combat progressed. Adjustments to rocket racks, trigger mechanisms, and ammunition storage increased both safety and efficiency. Crews learned how to stagger launches to avoid destabilizing the jeep, how to account for wind and terrain, and how to coordinate movements with infantry to maximize impact. Each successful engagement provided feedback, improving the effectiveness of subsequent operations. In this way, rocket jeeps evolved in real time, the battlefield itself serving as both proving ground and laboratory. The psychological impact on German troops cannot be overstated. Accounts describe soldiers hesitating behind trenches, uncertain where the next salvo would come from. Traditional defensive strategies were ineffective against a weapon that could strike from unexpected angles and then disappear into cover. German commanders had to commit additional resources to protect flanks, disperse fire, and anticipate threats that were neither tanks nor artillery, but a hybrid of both. This constant pressure disrupted planning, slowed movements, and contributed to an erosion of morale along the front. By mid-1944, the deployment of rocket jeeps expanded beyond Italy. Units in Normandy utilized the same principles: mobility, surprise, and concentrated firepower. Reconnaissance reported German lines reinforced with obstacles and machine guns. Yet the rocket jeeps adapted. They advanced along hedgerows, used terrain to their advantage, and delivered rocket salvos into positions that had been considered secure. Even heavily defended villages were vulnerable to these small, agile vehicles. And Allied commanders began to recognize that improvisation could outmatch conventional strength. The decisive factor was not just the rockets themselves, but the integration of human skill, tactical coordination, and technological adaptation. Each engagement demonstrated that the combination of mobility and firepower, applied with precision and initiative, could create outcomes far beyond the expected capability of the equipment. The rocket jeep was no longer an experiment. It was a validated weapons system capable of shaping battles and forcing adversaries to rethink defensive doctrine. At the end of Section 1, the stage is set for a further dramatic application. The peak of the rocket jeep's battlefield impact, where its use in critical operations would decisively influence the outcome of engagements. The summer of 1944 marked a pivotal moment on the Western Front. Operation Cobra, the Allied breakout from Normandy, required speed, precision, and concentrated firepower. German defenses were formidable, fortified by hedgerows, minefields, and entrenched infantry supported by artillery. Tanks and traditional artillery could only achieve so much in this terrain. It was here that the rocket jeeps, perfected through months of experimentation in Italy, would demonstrate their full potential. A small convoy of rocket-equipped jeeps advanced through the Bocage country. Drivers hugged narrow dirt lanes, avoiding ditches and crumbling walls, while crews loaded their rockets, checking angles and ignition systems. The air was thick with the scent of wet earth and gunpowder. At the designated moment, rockets streaked from the vehicles in rapid succession, arcing over hedgerows and detonating with concussive force among German positions. Machine gun nests were silenced, fortified bunkers damaged, and morale shattered. Infantry advanced behind this mobile barrage, moving through gaps that would have remained closed under conventional artillery fire. The effectiveness of the rocket jeeps in Normandy was amplified by their mobility. Unlike static artillery, which required careful positioning and time-consuming deployment, the jeeps could strike from multiple directions in quick succession. German units faced a dilemma: concentrate fire and risk being flanked by another volley from an unseen angle, or disperse and dilute defensive strength. The unpredictability forced rapid adaptation, often under fire, as commanders attempted to account for this new threat. Reports from the front describe the psychological impact vividly. German soldiers referred to these vehicles as ghost artillery, noting how they seemed to appear from nowhere, deliver destruction, and vanish before retaliation. This created confusion and hesitation, critical factors in a battle where timing and coordination could determine success or failure. American commanders capitalized on this, deploying rocket jeeps in coordinated strikes that synchronized with infantry advances, Sherman tank support, and aerial bombardment, creating a combined arms effect that overwhelmed defenders. One notable engagement involved a series of 3 rocket jeeps supporting an infantry push toward a key crossroads. The jeeps moved along concealed lanes, firing rockets in staggered intervals to maintain pressure. German positions were destroyed or abandoned, and Allied infantry captured the objective with minimal casualties. Field reports emphasized the efficiency of this approach. A few light vehicles delivering precise, mobile firepower could achieve results that would have required heavy artillery or prolonged bombardment. The lesson was clear. Mobility and adaptability could rival, and sometimes surpass, brute force. Engineers and crews refined operational techniques in real time. Crews learned how to stagger firing sequences to avoid destabilizing the vehicle, adjust launch angles for varying terrain, and coordinate movements to maximize coverage while minimizing exposure. Ammunition storage was optimized to maintain vehicle balance, and pre-positioned caches ensured that rocket teams could sustain operations over extended periods. This combination of preparation, improvisation, and execution turned the Jeep into a weapon that was both lethal and versatile. The German response, though earnest, struggled to match the flexibility of these small units. Conventional artillery batteries required setup, calculation, and support. Tanks were limited by terrain and numbers. The rocket jeeps, operating in small, agile teams, exploited every gap and weakness, striking unpredictably and retreating before effective countermeasures could be employed. Intelligence reports acknowledged both the audacity and effectiveness of this approach, noting that it challenged traditional assumptions about the relationship between vehicle size, firepower, and battlefield impact. By late summer 1944, the role of rocket jeeps had been fully validated. Operations across Italy and Normandy demonstrated that even lightly armored, improvised vehicles could have a decisive effect when mobility, coordination, and ingenuity were combined. The Americans had turned a simple, utilitarian vehicle into a tool capable of shaping engagements, supporting infantry, and disrupting entrenched defenses in ways previously thought it impossible. The climactic impact of rocket jeeps was not measured solely in destroyed positions or enemy casualties, but in the strategic shift they enabled. German units were forced to react continuously, reallocating resources to counter a threat that was mobile, flexible, and unpredictable. Commanders began to recognize that a battlefield advantage could be achieved not only through superior numbers or firepower, but through adaptability and the innovative use of existing assets. This decisive period of deployment solidified the rocket jeep's reputation among both Allied and German forces. American ingenuity, demonstrated in the transformation of a transport vehicle into a mobile rocket platform, had reshaped tactical doctrine and influenced subsequent operations. The vehicle had evolved from an experimental idea in workshops to a validated weapon system, capable of delivering concentrated firepower precisely, quickly, and unexpectedly. The biggest stage in the story examines the aftermath of these operations, the consequences for both armies, the official evaluations of effectiveness, and the broader implications for military innovation and doctrine. The battlefield lessons of rocket jeeps would resonate long after the smoke cleared, influencing design, strategy, and the perception of what was possible with ingenuity and determination. The battlefields of Italy and Normandy were littered with the remnants of conflict. Shattered buildings, scorched earth, and the echo of artillery fire. Amid this destruction, the impact of the rocket jeep was unmistakable. American commanders documented its effectiveness in after-action reports, noting how these vehicles provided mobile firepower, suppressed enemy positions, and facilitated infantry advances. Though small in size and lightly armored, the jeeps had achieved disproportionate influence on the outcome of multiple engagements. Evaluations emphasized both the tactical and psychological effects. German units, accustomed to predictable artillery patterns and armored assaults, faced a weapon that could strike from unexpected angles and vanish before retaliation. Soldiers reported confusion and fear, describing the vehicles as ghost artillery or miniature batteries. Even when outnumbered or outgunned, small groups of rocket jeeps could disrupt entire defensive lines. This unpredictability forced German commanders to allocate additional resources to counter what had been, in essence, a light, improvised vehicle. Official U.S. Army reports highlighted the practical lessons learned. Engineers had demonstrated that a standard Jeep chassis could support multiple rockets without catastrophic failure, provided modifications were carefully implemented. Launch angles, weight distribution, and vehicle reinforcement were all documented. Ammunition handling procedures were standardized to prevent misfires, and training manuals incorporated these lessons for future deployments. The result was a system that combined ingenuity with reliability, turning what began as a field experiment into an operational asset. Comparisons with German and Soviet systems underscored the innovation's significance. German Panzerwerfer units provided mobile rocket artillery, but they were larger, slower, and more vulnerable to counterattack. Soviet Katyushas delivered devastating barrages, yet required preparation and substantial crews. The American approach, using light, versatile vehicles, allowed rapid deployment, immediate firepower, and swift withdrawal, a mobility that rivaled the strategic advantage of heavier systems. Where Panzerwerfers and Katyushas relied on mass, rocket jeeps relied on surprise, speed, and flexibility. Soldiers in the field often recounted vivid anecdotes. A single jeep could fire multiple rockets into a fortified position, then retreat into cover, leaving German troops scrambling to respond. Infantry units came to rely on these vehicles for support during assaults, while engineers continued to modify designs to increase both the number of rockets and firing efficiency. These experiences reinforced the value of practical ingenuity on the battlefield. Small, adaptive innovations could yield results far exceeding their apparent mechanical limitations. The limitations of the rocket jeep were also clear. The vehicles were lightly armored, vulnerable to small arms and artillery fire. Accuracy decreased at longer ranges, and repeated launches stressed the chassis and suspension. Ammunition supply was a constant concern, requiring careful coordination to maintain operational effectiveness. Yet despite these challenges, the benefits consistently outweighed the drawbacks. The combination of mobility, firepower, and psychological impact proved decisive in multiple engagements. Beyond immediate tactical results, the rocket jeep influenced broader military thinking. American commanders began to recognize the potential of light, versatile vehicles in both offensive and defensive operations. The ability to integrate firepower into fast-moving platforms reshaped concepts of mobility and battlefield support. Lessons learned were incorporated into training programs, vehicle design standards, and operational planning, ensuring that the principles demonstrated by rocket jeeps would persist beyond the war. German assessments of these vehicles were both analytical and admiring. Post-battle reports described the ingenuity required to convert a utility vehicle into an effective weapons platform. Engineers noted the clever use of existing technology, the speed of adaptation, and the tactical ingenuity displayed by American forces. While these reports acknowledged that the vehicles were lightly armored and had limitations, they also highlighted the fundamental lesson: innovation in the field, even when improvised, could yield significant strategic advantages. The combination of combat success, operational evaluation, and enemy observation cemented the rocket jeep's place in military history. From the rocky hills of Italy to the hedgerows of Normandy, these small vehicles demonstrated that ingenuity, coordination, and mobility could challenge even the most well-prepared defenses. They had proven that effective weapons were not always defined by size or armor, but by adaptability, speed, and human skill. The aftermath of these operations set the stage for a broader analysis of their impact. Production decisions, post-war evaluations, and doctrinal changes would follow, reflecting both the lessons learned in combat and the lasting influence of American field innovation. The story of the rocket jeep was far from over, extending beyond the immediate battlefield to shape future military thinking and vehicle design. After the battles in Italy and Normandy, the U.S. Army began formally analyzing the rocket jeep's operational effectiveness. Field reports were compiled, highlighting successes, failures, and lessons for future development. Engineers noted that repeated testing under combat conditions had validated earlier modifications. Vehicles could sustain multiple launches, traverse difficult terrain, and deliver concentrated firepower with remarkable speed. Units trained specifically to operate rocket jeeps became an essential part of combined arms operations. their mobility allowing commanders to execute strategies that would have been impossible with conventional artillery alone. Post-war studies extended the analysis. American military theorists emphasized the importance of adaptability, speed, and field innovation. The rocket jeep exemplified the principle that ingenuity, rather than size or cost, could be decisive in combat. Lessons learned influenced the design of light vehicles for reconnaissance, rapid assault, and mobile fire support. Engineers studying the vehicles stressed modularity, a platform that could carry weapons, supplies, or reconnaissance equipment depending on the mission. This approach informed both Cold War vehicle programs and later conflicts, where small, mobile, armed platforms became standard tools in military arsenals. German engineers and military analysts also studied the phenomenon. Captured reports, battlefield sketches, and eyewitness accounts highlighted the audacity and efficiency of American improvisation. For officers trained to rely on precision engineering and methodical planning, the rocket jeep represented a departure from convention, a light vehicle adapted in the field, capable of delivering powerful, unpredictable strikes. Many acknowledge that despite its limitations, the rocket jeep had forced a re-evaluation of defensive doctrine and operational planning. It demonstrated that innovation could emerge from necessity and creativity, not just formal research and design. The operational lessons were clear. Mobility multiplied by firepower could disrupt enemy formations, force defensive realignment, and create opportunities for infantry and armored units. Rocket jeeps illustrated that small, light vehicles could complement larger, heavier assets on the battlefield, filling gaps that tanks or artillery could not reach. Supply chains adapted to the new reality, ensuring that ammunition and spare parts were available to maintain operational tempo. Crews were trained not only in vehicle operation, but also in tactical deployment, emphasizing coordination, timing, and precision. Beyond immediate military applications, the rocket jeep shaped broader thinking about warfare and innovation. Commanders began to recognize that rigid adherence to doctrine could be a liability when facing an adaptable opponent. The success of field-modified vehicles underscored the value of flexibility, improvisation, and decentralized decision-making. American forces had demonstrated that creativity, combined with rigorous training and discipline, could yield results that exceeded expectations. In the post-war period, the legacy of the rocket jeep continued to influence vehicle design. Light, mobile platforms capable of carrying rockets, missiles, or other weapon systems became a staple in U.S. and Allied militaries. Vietnam-era gun trucks, armored reconnaissance vehicles, and even modern rapid response units trace their conceptual origins to lessons learned with these improvised WW2 vehicles. Engineers and military planners repeatedly cited the principle demonstrated in Italy and Normandy. A vehicle's potential is defined not just by armor or firepower, but by how effectively it is integrated into combined operations. The psychological and cultural impact also endured. Soldiers who had operated or witnessed rocket jeeps carried stories of ingenuity and daring, shaping the collective memory of the war. The vehicles became emblematic of American adaptability. The ability to take a simple, functional object and transform it into a weapon capable of changing the course of engagements. Even in post-war military education, the story of the rocket jeep served as a case study in improvisation, resourcefulness, and the human element in technological innovation. Finally, the rocket jeep's influence reached beyond strictly military applications. Its example reinforced the principle that constraints in resources, terrain, or logistics could be overcome with creativity, collaboration, and practical engineering. The legacy was a testament to the interplay between human initiative and mechanical design. demonstrating that the ingenuity of individuals in the field could produce effects that rivaled the most carefully planned operations. As the war drew to a close, the rocket jeep had fulfilled its role. It had disrupted German defenses, provided critical support to infantry operations, and demonstrated that mobility and improvisation could rival sheer firepower. The vehicle's impact extended beyond the battlefield, shaping military doctrine, engineering practices, and the philosophy of innovation for decades to come. The stage was now set for reflection, to understand not just what the rocket jeep achieved, but what it represented in the broader sweep of history. The story of the rocket jeep is a story of ingenuity meeting necessity. What began as a simple utilitarian vehicle became a symbol of adaptability, creativity, and the transformative power of human initiative under pressure. Across the rugged hills of Italy and the hedgerows of Normandy, these light vehicles demonstrated that innovation could emerge from the field as much as from the factory, and that a small, clever modification could yield results far beyond the sum of its parts. In the broader context of warfare, the rocket jeep challenged assumptions about size, armor, and firepower. It proved that mobility, when paired with strategic creativity, could rival heavy artillery, and that flexibility often determined outcomes as much as planning. German forces, trained to respect brute force and engineering precision, confronted a weapon that defied expectation, a reminder that ingenuity can turn limitations into advantages. The human element was inseparable from the technology. Soldiers, engineers, and commanders all contributed to its evolution, blending practical knowledge, courage, and initiative. Each salvo fired from a jeep represented not only mechanical function, but a testament to the skill and adaptability of those who operated it. Their work transformed a civilian engine into a tactical asset that reshaped battles and influenced military thought long after the conflict ended. Beyond its immediate effects, the rocket jeep left a legacy in military design and doctrine. Light, versatile platforms capable of delivering concentrated firepower became a template for post-war vehicles, influencing reconnaissance, rapid response, and mobile artillery strategies. It reinforced the lesson that innovation often arises where necessity, creativity, and opportunity intersect, a principle that continues to shape armed forces around the world. Ultimately, the rocket jeep reminds us that warfare is not only a contest of machines and weapons, but of imagination, adaptability, and human resolve. In the echoes of engines and the trails of rockets across scarred landscapes, one sees a lesson that transcends history. Even the humblest invention, when guided by ingenuity and courage, can alter the course of events and leave a lasting mark on the story of humanity.